Hi guys, we're going to do a video on geometric transformations, rotation specifically, which is a form of rigid motion. First, we're going to talk about what geometric rotations are. Then we're going to look at some examples around the origin. Then we're going to look at a few examples around a point that is not the origin. Let's get started. So as I mentioned in a previous video, we're talking about rigid motion, and what rigid motion means is that we're going to rotate an object without changing any of its dimensions. So we're not going to change the length of its sides or the sides of its angles. So what is a rotation? A rotation is moving an object around a point, and in this case we're going to use the origin and we're going to rotate around the origin. But not only does it slide like a translation, but it also changes orientation. The reason why the orientation changed is because we're not sliding in a straight line. What we're actually doing is creating a circle around that point. Typically, rotations are broken up into quarters, such as 90 degrees, 180, and 270, then back to where we started. We typically don't rotate an object 360 degrees because that means you would just leave it where it is. Rotations are, by standard, counterclockwise, so turning to the left, unless stated otherwise. So now let's take a look at a couple of examples. Example 1, we're going to rotate around the origin, which is 0, 0, 90 degrees. So there's a bunch of ways to do this. One is an algorithm. I will link the video to this Professor X looking dude who does a good job of presenting the algorithm for you. I will, in contrast, rotate the object or the pre-image physically. I prefer not to use algorithms. I find them hard to memorize, hard to remember, and also algorithms tend to be very specific for specific cases. I like to learn rules, so therefore I only need to know one set of rules and then apply them. So let's take a look. Because I'm on a graph, what I could do is I can create a line from my center of rotation to a chosen point. So what I'm going to do is I'm going to slope count to this point. I chose that point because it's just the closest one. So for right now I'm going to count up 2, right 3, which creates a positive slope line. So I have up 2, right 3. And knowing my properties of straight lines, I know that I could create a perpendicular line, which this is the symbol for perpendicular, by just finding the negative reciprocal slope. So I am going to flip and create the negative reciprocal. Well, now what that means is I am going to count and create a negative line. So from my center of rotation, I'm going to count up 3, 1, 2, 3. Then, instead of to the right, I'm going to count left 2, 1, 2, creating a negative line. I'm going to draw these lines for this example, though typically I don't do this. Now what I'm going to do is do this with my other 2 points. So I'm going to count up 1, 2, then 1, 2, 3, 4, 5. So that's 2 over 5 from here. And now what I have to do is create a negative slope or the negative reciprocal. And now what I'm going to do is I'm going to count up 1, 2, 3, 4, 5. Then to the left 2. Okay, so I found 2 points. Now, there's a couple of things I can do here. I brought this up in my previous video with translations. If I can orient the shape, I really can just carry my third point over. So in this case, I know that I am turning to the left. That means my triangle is going to be pointing to the left, which will be in this direction. And the third point is in the middle of these 2 points and 3 away. So I could plot my third point here using that logic. Or what I can do is I can just count up, slope count 1, 2, 3, that's 5. Then 1, 2, 3, 4. So I can once again, if I need to, just create the negative reciprocal and count this way. So I'm going to count 1, 2, 3, 4 up, 1, 2, 3, 4, 5. Creating my image. Okay, the last thing I want to show you here before we really get in depth, if you look at my previous slide, we essentially create a circle around the center of rotation. So if you kind of notice what I'm doing here, I'm creating these concentric circles. This is very, very straightforward to do if you know how to use a geometric compass, which is how I would recommend rotating as opposed to using an algorithm. Unfortunately, I don't have one here, so I don't have that function in PowerPoint, so I'm kind of just scribbling the circles on for you. But all of the points are staying equal distance from the center of rotation. Okay, let's look at the next example. So the next example again is looking at rotating along the origin. And what I did is we're rotating 180 degrees and I placed that CCW abbreviation there. And what that means is counterclockwise. So let's take a look at this one. So I'm going to slope count again. So I'm going to count up 2 over 3. But I don't need to create that negative reciprocal line. All I need to do is just continue the line in the other direction. So let's see here. I have a slope of 2, 3, which is double positive. Well, if I want to extend this line in the other direction, the easy way to do that is just to make double negative. So again, if you know how to graph linear functions, this should be pretty straightforward because we're using the same exact properties or the same exact rules because the rules never change. So here, what I'm going to do is I'm just going to count down 2 and to the right 3 and create my new point. I'm going to do that for each of these. And if you notice, all I'm doing is extending the line. Now I'm not going to draw all those lines again. I don't want to muddy all this up. So again, 2, 5 becomes negative 2, negative 5. I guess I could draw an arrow there for what it becomes. And I'm just going to graph. So knowing that this is a 180 degree rotation, I know that my triangle, which is pointed up, will now be pointed in the opposite direction or down. I again can plot that third point without having to make all those lines. But if you need to, you literally just keep following the same steps over and over and over again. And that starts to sound like an algorithm. But what you're essentially doing is applying the same rules over and over and over again, which is different, in my opinion. Next, let's take a look at how the rules apply when we rotate around a point. Okay, so this time what I'm going to do is I'm going to rotate around the point 1, 2. This is a fairly clean rotation. So let's get started. Okay, this is directly to the right of my center of rotation, this point here. So the perpendicular line would be just up. Then I'm going to do that with my other. So now I'm going to count to the right. 1, 2, 3, 4. So I'm going to count 1, 2, 3, 4. Up. Now let's just follow those same rules for my third point. In this case, this is a pretty square rotation here. To get to my third point, I'm going to count up 1, 2, 3, then over 1, 2, 3. So that creates that slope of 3, 3. And the negative reciprocal is simply negative 3 over 3. So what I'm going to do is I'm just going to count up 1, 2, 3, but instead go to the left, 1, 2, 3, creating my image from my pre-image. Okay, let's take a look at one last example, and I also want to cover 270. So we're going to rotate 180 around the point. I purposely moved the point down to make this a little bit harder and not as clean as the first one. But I'm going to follow the same exact rules as I did before when I rotated 180 around the origin. So I'm going to count up 1, 2, 3, 4, and to the right 1, 2. Well, I can make that double negative by counting down 1, 2, 3, 4, and to the left, making my point there. I am then going to do the same thing by counting 1, 2, 3, 4, up, 1, 2, 4, to the right. So I'm just going to count 1, 2, 3, 4, down, 1, 2, 3, 4, to the left, making a double negative. Now I could just know that I'm pointing my triangle downwards, or what I could do is just follow the steps for a third time. So I'm going to count 1, 2, 3, 4, 5, 6, 7 up, then 1, 2, 3 to the right. So now I'm going to make a double negative again by counting down 1, 2, 3, 4, 5, 6, 7. Then to the left 1, 2, 3, creating my new shape or image from the pre-image. Now I want to take a second and I want to cover what 270 looks like. So we're going to cross this out and we're going to call this 270 degrees. So let's take a look. If you recall, when we found the 90 degrees, what we did is we counted up 1, 2, 3, 4 over 2. Then what I did is I got the negative reciprocal of negative 2 over 4. Well, if I want to, I could count up 2, left 4, making a negative line, placing my point here. The other way to make a negative line is to go down 2, right 4, 1, 2, 3, 4. I could do that for all of my slopes now. So I took all of my slopes that I originally counted and I found the negative reciprocals. So now I'm going to count them out. But instead of always counting to the 90 degree space, I'm going to count to my 270. So I'm going to count down 1, 2, 3, 4, and to the right 1, 2, 3, 4, making this point here. And now I'm going to count the next one. So I'm going to count down 1, 2, 3, then to the right 1, 2, 3, 4, 5, 6, 7. Again, if you know which way your shape is pointing, then you can just, I guess, orientate that last point based on the other 2 points, and that will be 270. So we have 180 degrees here, 270 here, then we're going to make 90 degrees real quick here, and then I want to show you one last thing before we close out the video. So I know this is exceptionally sloppy. I don't have access to a geometric compass tool for PowerPoint, and also the PowerPoint circle function is just a nightmare to use. So I just kind of scribbled them on here. But what I want you to see is what we created was a bunch of concentric circles around a point, or a bunch of orbits around the point. So each point of the shape or the pre-image is essentially orbiting the center of rotation. When I do rotations on paper, I typically use a compass and just create these circles. Then create the perpendicular lines. I cut the space up into quarters and then place my points where I want. From there, I can make almost any rotation I want, because if I know how to use a compass, I can just bisect my angles and create all those different points, which is actually a lot of fun. Alright guys, I hope you guys found this video helpful.